Okay.
Yeah, so what's my
Good
theme,
topic.
everyone? What's my theme, right? What's my theme, right? Always why. So our topic is first hop redundancy protocols, or FHRP. Why do we need FHRP? What are we solving, right? So I'm asking why because I want you to have that in your head when we're going through this. Even if you know it or don't know it, I want you to think about why. Like always, why are we doing this? Why is it needed? What's the protocol's purpose? And you have, some of you have it, right? Redundant gateway redundancy.
Yeah.
So what I said here is, where's my default gateway, right? Where is my default gateway? I'm looking for my default gateway as a client. And what happens if my default gateway goes down? So FHRP is to solve my default gateway single points of failure issues, right? Provide routing redundancy for access layer. Again, we're not talking about routing protocols here, but we're talking about that default gateway. And we need a redundant solution for our default gateways. And this is independent of the routing protocols, right? It's totally independent of the routing protocols. And for some of these deployments, you can actually do sub-second failover. I would always caveat that with, make sure there's a reason, right? Make sure there's actually a business reason to have a sub-second failover of your FHRP, right? Don't configure it just because. Yeah. And then in certain circumstances, you can get provide a load sharing capability versus a redundancy option, right? You can actually load share traffic, and that's specific to GLBP, which we'll get into in a minute at a high level, right? It is, Brock. Yeah. So the question was, is it possible to use BFD with HSRP and VRRP? It is, for sure. And it's recommended if, I would definitely do it if you're going to do any type of tracking of the links. So in some design situations, you might need to track an interface to bring HSRP or VRRP down, because you want to make sure when that link goes down that the default gateway goes down and everything fails over to another path throughout the architecture. I don't have a diagram specifically for that use case, but I can create one and share it just so you have it. But it's a good use case too, to use BFD and track the interfaces. All right. There's three options: HSRP, VRRP, and GLBP. We're not going to go into all the details of HSRP or VRRP, right? That's not the point. We're not going into the how, right? We're not going into the how here, but I do want to compare some of the settings between these two. And the reason why I'm comparing it is because HSRP and VRRP are very similar. They're very similar on design and how you implement it. All right. So these are this is just a chart for you to have. One of the key things I'd highlight here is the preemption default, right? So preemption means that my redundant default gateways that are in the solution, my redundant devices can preempt things. They can, when something goes down, the other device is going to take over. But when that primary device comes back online, it can take that default primary role back over. And there's a preemption delay as well. And you usually want your preemption delay to be higher than it takes for your device to come online, right? All the boot process and all the protocols coming online. So if that takes 10 minutes, you want your preemption delay to be like 15 minutes.
Yeah.
And Barack has a question. What do you think about preemption? I always use it. That's just me. Because when we're going to get into it, the aligning to spanning tree, your root bridge is going to come back online, and that primary root bridge is going to be a device. So you want your root bridge and your primary HSRP or VRRP device to be the same, or else you're going to have an incorrect traffic flow.
Yeah,
and there's a diagram in a minute to show that.
Yeah. So I agree with the Zig. Always recommended enable the preemption, but configure the preemption delay. So so this is the best toward. Yeah.
And we have a big question in there, Mohammed. Maybe we'll table that on top of HSRP for Magnus. I can't read the whole thing in the time I have right now. So I'll take that and we can look at it in a minute.
Sure. So the whole configuration. This one maybe we need to address it on the next one.
So here's a load sharing example, right? We're back to a topology. We have the same switches. We have an access switch and two distribution switches. We have two different devices here. Right, we have a switch, a laptop on the left side, a laptop on the right side. And this, we also have internet cloud, right? How do we get to the internet, right? Our primary root bridge is DSW1 still, and our secondary root bridge is DSW2. The point here is that these are the root bridges for everything. Primaries on the left and secondaries on the right. So in this architecture, let's say we have VLAN 44 here for that access switch, and we have VLAN 22 for this edge device. I said access switch, I meant edge device, right? They're different VLANs. So let's color code them to make it really easy. So I have purple for 44 and I have green for 22. And let's track this down. Who's going to be the active HSRP? And I use HSRP as an example. This would be the same thing for VRRP, just so we're clear. HSRP group 44 for VLAN 44, DSW1, that distribution switch 1 would be the active member, the primary member for that group, that default gateway. Also, the root bridge for VLAN 44, that Spanish root bridge would be on DSW1 as well. Now, DSW2 would be the standby for HSRP group 44. Hopefully that makes sense. The point I'm trying to show here is how this flow would work from a VLAN 44 perspective. So as you just saw, that purple line went from the device to the access switch, to the first distribution switch, and then out to the internet, right? Now, if we track the same process with VLAN 22, but we alternate who is the primary root bridge and who is the primary HSRP member. So DSW2 is going to be the primary for VLAN 22, the green VLAN. So the root bridge is DSW2, and the active default gateway for HSRP is DSW2 as well. So that traffic flow is going to be different. But here, because we're doing it like this, we can actually use all of our links effectively. We can split our load. I'm hoping that paints the picture correctly, but that's load sharing as best as we can with HSRP and VRRP. And this example is on 2 different VLANs, but you could scale this out and say all my even VLANs, all my odd VLANs.
Exactly.
Right?
100%.
You could also do this in a single VLAN. You're right, Christian. Right? You could also do this in a single VLAN with multiple default gateways if you wanted. Multiple default gateways. You could have a number of default gateways. I prefer not to do that, but there is a good use case for like data centers, with you're spanning multiple data centers, and then you might need multiple default gateways for a single VLAN.
There's a couple of questions here, Zig. I'll try to answer them. Zig, sorry if I read your name incorrectly.
You're good.
Asking if you can use VSS. I believe this is an option. And I remember, as Christian mentioned, all days was Catalyst 6500 when you have like 2 distribution switches and use as a VSS. This will simplify things to the access layer, because these 2 switches will be like logically 1 switch. Also, I believe with the Nexus 5K and 7K, this can be supported with VCP, which is similar to VSS. But even for this situation, I remember that when you configure even VSS, we usually keep spanning tree as a safeguard. So even when you have this situation, you keep spanning tree on the background, just in case of something wrong happening between these 2, like brain split or so on. Second question, do you recommend to decrease the HSRP timers? Yes, you can do. With HSRP, I believe you can go to the sub-second, like a couple of hundred of milliseconds. For BFD, you can go a bit faster. That depends on the vendor. They support 50 millisecond keep alive or so on, so you can convert maybe in 150 milliseconds. Last comment from Kristen Thompson. Load share design, you can also do this in a single VLAN. Yeah, I believe in a single VLAN, that's operational nightmare. I believe you covered this point, Zig, about how to load balance.
I did.
Yeah. Okay.
But we don't have to Christian's point, it is a nightmare, right? It's totally a nightmare. So the HSRP timers for sub-second, I wouldn't go lower than 200 milliseconds, right? So I would keep it around 200 milliseconds, 250 milliseconds. If you go lower than that without BFD, you could get some CPU issues, right? So at that point, I would use BFD to help you increase the convergence even further than that if you needed it to be further. But remember, make sure there's a reason, right? Don't just do sub-second failover if you don't have a reason.
Yeah, yes.
All right. All right. So GLBP, right? And this is a specific